Okay, so today we're going to take what we did yesterday with box method and we're going to make visuals. And Stormy just said something that was mathematically genius. So Stormy, can you repeat it, what you just said?
So is it just like you're using the box but you're breaking the numbers up into arrays?
That's it. So we're taking the box that we did yesterday, breaking our number apart, and we're making arrays. We're making a picture out of this so that we can see, one, why the box method works, and two, why 2-digit by 2-digit multiplication creates such large products. So we can visualize it. So those of us whose brains like pictures, we can see it. Yes, ma'am?
On one of the math bonus, have we done this?
Yes, we did this. We did this in a math bonus 2 weeks ago with the multiple digit by 1-digit factors. Remember we did it in small group with the blocks. Remember we made them? Yeah. We're not going to make 28 groups of 41 with blocks. No, it'll just take too long. And I know box method already takes a little more time, especially if you don't know your facts. And this is going to take us a little bit of time. So we're just going to draw the pictures. Okay? This first one will take a little bit of time, and then we'll do another one where you'll see how it connects, like Stormy said, to the box method. So the first step, we're going to write out and break apart our numbers. Okay? So let's look at 28. Look up a factor of 28. Let's look at it and let's break it apart. What does 28 break into? Cortland?
20 plus 8.
20 plus 8. And I like how you were already doing box method, you already are thinking about it in your notes. So 20 plus 8. Now, with blocks, before I break up my other one, what does 20 plus 8 look like with place value blocks? What does it look like? How many 10s, how many 1s, that kind of thing. What's it look like, Freddie?
2 10s and 8 1s.
So 2 10s like this, 2 10, those longs that we use, and then 8 1s. 1, 2, 3, 4, 5, 6, 7, 8. Do you see what I did there?
Yes.
I know on the screen my little green dots are really small, but they're there. Okay? You can kind of see them. Yeah. So then if I break up my second factor, what does that break into, Alana?
40 plus 1.
40 plus 1. So I'm going to write that just like I would with box method, kind of sideways over here. So I've got 40 plus 1. I know it looks like 40 plus minus sign, but I'm just writing it sideways so I can really see it. How many... this is going to get crazy, y'all. Okay? Can you stop and start imagining how many 10s do I need? I can't do that on the screen because nobody can see it, so let me do this. How many 10s do I need right here? Everybody? 40. Because it's 40 times that 110. And then I need another 40 right here. Yeah, like Stormy said, oh shoot, this is why we're not building it with the blocks. So let's watch the connection to box method. I am not going to draw all of those lines. No. So what I'm going to do now is draw my box so I can see how this connects to box method. Yeah? Yeah, that's what I want to hear. I see it. I get it. Yeah. Oh. Parents, if you're watching this is why we do this crazy math, for that little moment. Okay? And we will get to the way that everybody else has learned to multiply. And I know that it takes a long time. But now you're seeing it so that when we do just regular standard algorithm, we're doing up and over, you're going to understand why the numbers are so big and why we put zeros where we put zeros, because of this visual. Okay? So now 40 times 20, 40 groups of 20. What is...
Crazy.
That's crazy, right? Do you want to draw all those out, Elena?
No.
No, so can we just do box method? Yeah. Okay, so let's just do box method instead of drawing this crazy out. What is 40 times 20? What's 40 times 20? Steven?
800.
800. Beautiful. So I see there's 2 zeros, and then I see my basic fact of 4 times 2. It's 800. Mm-hmm. Could you imagine? That's 80 tens, y'all.
Wow. I'll be
80 tens. That would be all of those blocks. 80 tens.
Jeez Louise.
Right, too much. It's too much. Okay. Now what about 40 times 8? What about 40 times 8? What is 40 times 8? These 8 and 4 facts, they're tricky. Layla?
32. So it's 320.
Beautiful. 4 times 8 is 32, so it's 320. Okay? Now imagine that's the 8 ones, those little ones, 40 times. Like huge. It's huge. That's why this number is so huge. Oh, and I like what we have in our ones place here, though, because that makes life easy. But before we do that multiplication and make life so easy, can you talk to me about what that property is called when I'm multiplying everything by this little sideways 1 here? What is that property called? Let's get a different person. Somebody else. Come on. What is that property called when you multiply by 1?
Identity property.
Yes, the identity property. So what's 1 times 20, everybody?
20.
Beautiful. What's 1 times 8, everybody?
8.
Okay, so now I have to add up all of my partial products. So add up your partial products. While you're doing this, another way you may see this is with a grid. Like on grid paper. So you would see 800 squares where the 800 is. You would see 20 squares where the 20 is. It'd be a big grid, but you'd see that. But that's why box method's nice, right? And the connection from the visual to box.
Very nice.
So you're adding up, I like it, very nice. You're adding up your products, your partial products, so we can get the total product. What was your product? What was your final product, Moses?
It is 1,148.
Beautiful. It's 1,148. Yay. Okay, so we're going to do another one. This one we are going to draw the picture so that you can see exactly what it looks like, but it's going to be a smaller factors. Because you saw why box method is beautiful, but let's visualize. Because some mathematicians were asking, like, what does it look like? What might it look like? So let's do that. So this problem, we are going to do 17 times 13. Okay, 17 groups of 13. So this one will not be as huge as our first one, and we can actually draw or use the place value blocks to see the array. Or if you have grid paper at home, grid paper works real nice with this too. All right? Your notes are looking nice. So what is our first step? Again, what's our first step when we're building these arrays or we're doing box method? What's the first step, Raymond?
Blocks.
What?
We draw the blocks.
Oh, we can draw the blocks, but before we draw the blocks, what do we have to do?
Break it up.
Break it up. So let's break up 17. Okay, let's break up 17. Let me make my dot bigger so we can really see this. What does 17 break into? What does 17 break into?
10 plus 7.
10 plus 7. So watch me draw this picture. There's my 10, right? The long. And then what am I going to draw next to it? What am I going to draw next to it?
7 1 blocks.
7 1 blocks. Now, mathematicians, I want you to look at how I do it. Because to make an array, can I group the ones?
Yes.
No, not to make an array.
Oh.
Because if they're in a group, I'm doing groups of. To make an array, I need rows and columns. So my ones need to be like this. 1, 2, 3, 4, 5. Whoops, too many. It's only 3. Oh, no, it's 17. I'm right. I'm not doing 13. 10, 11, 12, 13, 14, 15, 16, 17. See what I did there?
Yes.
Okay. Now, the other number that I have to break up is, yes, ma'am,
13.
13, which breaks up into what? Yes, sir.
10 plus 3.
10 plus 3. And again, I'm just going to kind of, or I didn't write it out. I apologize. So up here, I have 10 plus 7. And then over here, I'm going to have 10 plus 3. So how many 10s do I need right here?
1.
10. Good job, Zeke. Because it's 10 groups of 10. So I already have one. So let's see. 1, 2. Oh, I didn't make my line bigger. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ten groups of 10. 10 times 10, right? Is 100. So didn't I just make 100 block right here?
Yep.
So really all this is 10 times 10 equals 100.
It's easy because you drop down to zeros.
Yeah, it's easy. It's a basic fact, right, Zeke? I know 10 times 10 is 100. When I have 10 blocks, I get the 100 block. How many 10s do I need right here? Because here's my 10 up here. And then here's my 3 down here. How many 10s do I need in this particular part of the picture?
3.
3. I need 3 10s now. So now I just have 1, 2, 3. So what does that equal? 3 groups of 10. What does that equal? 1. 30. So that one looks like 10 times 3 equals 30. So I already have 1 partial product, 2 partial products. Am I done?
No.
No. Now comes the more tedious part, these ones. How many groups of 7, there's my 7, how many groups of 7 do I need over here? Look at your visual. How many groups of 7 do I need? Yes, ma'am?
1.
No, not 1, because I already have 1 group of 7. Does that fill in my array? Because remember, this is like a giant box method.
Oh, 10.
10. Very good. This is like a giant box method, just with a picture inside of it. I need 10 groups of 7. Oh, here we go. I already have 1. 1, 2, 3, 4, 5, 6, 7. 2, 2, 3, 4, 5, 6, 7. 3, 2, 3, 4, 5, 6, 7. 4, 2, 3, 4, 5, 6, 7. 5, 2, 3, 4, 5, 6, 7. 6, 2, 3, 4, 5, 6, 7. Why am I the only one doing this? 7, 2, 3, 4, 5, 6, 7. 8, 2, 3, 4, 5, 6, 7. 9, 2, 3, 4, 5, 6, 7. 10, 2, 3, 4, 5, 6, 7. So what is that? 10 groups of 7. What is that? 70. Do you see this? I can already tell that his brain is visual because you notice how he's popping out those products so much faster? This is why we do this. And some of you are like, I don't know. Like, I don't like the picture. I just want to go back to box method. But that's okay. So this is 10 times 7, which equals, like Zeke told us, 70. So now I've got another partial product. What am I missing? What am I missing? Yeah?
The bottom.
Which is what 2 numbers starting to multiply?
3 times 7.
3 times 7, I need 3 groups of 7. So here we go. 1, 2, 3, 4, 5, 6, 7. 2, 2, 3, 4, 5, 6, 7. 3, 2, 3, 4, 5, 6, 7. So 3 groups of 7. Oh, I heard some people. 21. So this one I have 3 times 7, and that equals 21. Same thing as your box method, but with your picture. I have all my partial products, so I can add them up. I have 100 plus 70, which is 170, plus 30. What is that? No. 200. 0 plus 0 is 0. 7 plus 3 is 10. Regroup. 200 plus 21. 221. Good. So that's the connection between box method and a picture. Okay? You could fill it up with blocks. Do you see that connection?
Yes. Yeah.
Awesome. Okay, so we'll save this. We'll put it on the YouTube so that you can make that connection. Tomorrow, distributive property. Thursday, standard algorithm.
Yay.
Building our way to doing it just up and down so we understand the visual, how it looks, why we get the big numbers that we do, the place value of it, and knowing our facts.